Hi friends, welcome to this important class on polynomials where we're going to discuss the remainder and factor theorem. And I'm going to make these theorems really easy for you. So I'm sure you'll find the concepts really easy after watching this class. So be sure to watch the entire video. So alright guys, I hope you're excited to learn these concepts. Let's go ahead and start. And before we start guys, I want to say we have this website manochaacademy.com, so do check it out, where we have physics and chemistry courses for class 9 and 10, and we've also started our special live classes on our website. So guys, do check out our website. We've got big discounts going on and I'll put the links below. We have interactive videos, you can attend special live classes, there's quizzes and questions, and you get direct replies from me. And great to see all of you here. Good evening everyone. Welcome to this important class on the remainder and factor theorem. So guys, and if you haven't subscribed to our YouTube channel already, hit the subscribe button right now and click on the notification bell so that you don't miss out on any of the live classes and the videos that we upload. And please do share it out with your friends so that we can have more people join us. And guys, if you haven't hit the like button, do hit it right now. And do check out our website manochaacademy.com. Alright, let's go ahead and start. So let's start with a very simple example. What do we mean by quotient and remainder? So guys, when you do this division, right? So when you're dividing 17 by 3, so how do we do that guys? It's going to be, right? 3 times 5 is 15 and this is our remainder. Okay, so what are the terms we use here? This is our dividend, right? So that's our dividend. We have our divisor here, right? This is the divisor. This guys is the quotient, and this you know is the remainder, right? So everyone I'm sure is familiar with these terms. So what can we write it guys? So we can write this whole thing as dividend equals, so dividend equals divisor times, so multiplied by the quotient plus remainder, right? Simple. So if you look at this example, what did we have there? So in this example, we basically have 17 equals, the divisor is 3, so 3 times 5 plus 2. So can you see that, right? So dividend is divisor times quotient plus remainder. Clear? Very good. So this is our simple way we are dividing numbers. And similarly guys, you know, we can divide polynomials. Can you see these polynomials here? So let's go ahead and do this division. So if we go ahead and do the division, x minus, so we are going to divide this thing, this polynomial x squared minus 5x plus 6, we're going to divide it with the x minus 2. Okay, so if we do this division, let's go ahead and do it really quickly. So we'll get x squared minus 2x here, right? And then the sign changes. So you're basically going to get minus 3x plus 6 here. And so that's going to be x minus 3, right? And so we'll get minus 3x plus 6. So again, the sign will change. And so this will cancel and we get a remainder of 0. So everyone's familiar with this, right? And good evening, welcome everyone. I see a lot of you are here on this chat. So please pay attention to this important class on remainder and factor theorem. And we've started with this simple polynomial division, right? And similarly, we can divide this also. So here, can you see guys, this is our remainder. So this is the quotient we've got. This is our final quotient and this is the remainder, right? So we can, for this polynomial, we can write the polynomial fx equals x squared minus 5x plus 6, and this can be expressed as x minus 2, so the divisor times the quotient, which is x minus 3 plus the remainder, right? So let me create some space here guys. So let's write this here, x minus 2 and plus our 0. So let's draw this line so that you can see the separation guys. Clear? So just like we wrote this, dividend is divisor times quotient plus remainder. We've expressed this same division in this form, right? Pretty simple. So look here, it's pretty simple. We've taken this polynomial and we can express the polynomial, the dividend as, so you can see here, this is our dividend, right? And that's equal to the divisor here. Can you see x minus 2? So the divisor times the quotient, which is x minus 3 plus our remainder, right? So very simple. I've just taken this division and I've written it in this form, right? Similarly, let's do the other division also so that we are crystal clear about these concepts. So if I do, and then we are coming to the remainder and factor theorem, right? So let's understand the basic idea. So if we now divide the same polynomial with this thing, with x plus 1. So let's see what do we get here. So this is going to be x, so that's x squared plus x here. And if we subtract, we are going to get minus 6x plus 6. And so this is going to be minus 6 here. So minus 6x and a minus 6. So now the sign changes. This will cancel, right? And so we'll get a, what do we get, guys? We get a remainder of 12 here. Can you see that, right? So this time the quotient is this thing. This is our quotient and the remainder is 12. Okay, so are all of you seeing that? So we can express this polynomial that we have here. So we can write for this question, right? So we can say fx is basically x squared minus 5x plus 6. Okay, so I think that's not very visible. So let me write it on this side. Right, so let's write it up here. So we have fx equals x squared minus 5x plus 6. And so that can again be expressed as divisor times the quotient, right? So the divisor is x plus 1, simple. X plus 1 times our quotient is x minus 6 here. And plus the remainder, this time we got 12. Okay, so guys, take a careful look at what we've done here. So this is for our second division and this line is for our first division. So pretty simple, just like we divide numbers, we are dividing the polynomials here, right? In algebra, we divide the polynomials. So now the interesting thing is, let's look at our first example. If we take x minus 2, so please carefully follow me here, that if we take our divisor, right? If we take x minus 2 as 0, so if we make the divisor 0, which basically means x minus 2 is equal to 0, right? So therefore we can say, or we can say that x is equal to 2. So now let's substitute that value x equal to 2 into this polynomial, right? So let's see what do we get here. So let's erase this. So what are we doing? We are setting our divisor. So carefully follow this, guys. We are setting our divisor to be 0 and we'll see why. So we are setting the divisor to be 0, and if we set the divisor to be 0, x minus 2 is 0. So basically we are saying x is equal to 2. Okay, so let's put x equal to 2 in our polynomial. So we are going to get f of 2 is going to be equal to 2 squared minus 5 times 2 plus 6. So very simple, I'm just substituting x equal to 2 and you can see that we'll get 0, right? 4 minus 10 plus 6. Okay, so why do we get that, guys? Because we get our remainder, because when we substitute x minus 2 as 0, this entire term becomes 0, right? So as you can see here, this term becomes 0. So this entire multiplication is going to be 0. So basically our f2 is going to be 0, which is the remainder here. So we are left with the remainder, right? Now let's try this thing. Okay, some of you joined us late, don't worry, it's pretty simple. Take a look at this next example here. So we are going to do the same thing. So we express this entire division in this form, right? Where this is the divisor times quotient plus 12. Can you see that? So this is our divisor and this whole big thing, the polynomial, is our dividend. So we've just expressed it in this form. Okay, and now we'll do the same thing here. We are going to set the divisor to be 0, this guy, right? We want to set our divisor to be 0, means this term. So what do we do for that? Basically, x plus 1 is equal to 0, right? So if x plus 1 is equal to 0, we are going to basically get x equal to minus 1, right? So when the divisor, note we are setting the divisor to be 0. Why? Because we want this entire term to disappear. So what are we left with here, guys? So what will we get? We are going to basically get here f of minus 1. So we're going to substitute that, and this entire thing is going to become 0, right? So f of minus 1 is minus 1 whole square minus 5 times minus 1 plus 6, okay? And if you calculate that, you're basically going to get 12 here, right? So this thing, yeah, so that's going to work out to be 12, which is our remainder, okay? So guys, see what are we doing here? We are basically setting our divisor to be 0, and so f of minus 1 is turning out to be 12, which is the remainder, okay? So what is the interesting thing that guys, you see here, that if you want to find the remainder, okay, so we've done two divisions here. So this was our first division and this was the second division. So if you want to find the remainder without doing the division, what is the trick you can do? You can set the divisor equal to 0, okay? So please look here, we are trying to find the remainder without doing division, right? So if you want to find the remainder without doing the division, all we are doing here, the important thing is we are setting the divisor equal to 0, right? And which basically means when you set it equal to 0, then that value of x, so x minus 2 is 0, so x becomes 2. So you substitute the value in the polynomial and then you'll automatically get the remainder. So here we substituted f of 2 and we got the remainder as 0. Here we substituted f of minus 1 here, right? And we got the remainder 12. So this is the concept of remainder theorem which I am coming to. So take a look here, guys. So what does the remainder theorem says? That if you take any polynomial, whether it's px or f of x, so let fx be a polynomial of degree greater than 1 and a be a real number, okay? So a is a real number. Then when you're dividing the polynomial fx by x minus a, the remainder is going to be f of a, okay? So let's connect this with our previous division so that you guys understand it. So look here, when we were dividing this first polynomial, so if you follow me, this was our polynomial x squared minus 5x plus 6. When we divided this thing by x minus 2, right? So to get the remainder, we substituted x minus 2 as 0, so we took f of 2. So similarly, we did for the other thing, to find the remainder, we did f of minus 1. So basically, what is the remainder theorem telling us? That you don't need to do division. You can quickly find the remainder. So when you take any polynomial, when you divide it by x minus a, look here, then you can easily find the remainder by doing f of a, right? Okay, so why is that? So if you look at the polynomial, so the polynomial is basically, it can be expressed of this form, fx, right? And you have this, you're basically dividing by x minus a, so this is our divisor, right? And then you're going to get some quotient plus a remainder, right? So we can express anything as, any polynomial as, this is the polynomial or the dividend equals the divisor times quotient plus remainder. And now when you set this x, you find f of a, basically you're setting x minus a equal to 0. So when you set this equal to 0, this entire term is going to get cancelled. So you can see that f of a will equal to the remainder. So this is the entire concept, guys. Okay, so please take a look here, right? Please take a look at this. F of x, so here's the whole beauty of the remainder theorem. F of x is equal to x minus a. Let me just erase that yellow line for a second here, and you can follow that once again. So guys, listen to this part really carefully. Any polynomial, as we saw when you do divisions, right, or you do the simple division, you can express anything as dividend is divisor times quotient plus remainder. So we can say any polynomial fx can be expressed as x minus a, which is our divisor here. So this is the divisor times quotient plus remainder. Simple. So dividend is going to be divisor times quotient plus remainder. All of you know that. And now when you want to find the remainder without dividing, what you can do is you can set this divisor equal to 0. That means therefore x minus a is equal to 0, or we are using x equal to a. So we basically go and substitute x equal to a in our polynomial. So we get f of a is equal to the remainder, because this entire term is going to get cancelled. Okay, so very simple. All you guys need to do here is that when fx is divided by x minus a, you just need to take the remainder as f of a. Alright guys, so simple that when fx is divided by x minus a, the remainder is going to be f of a. Okay, so now I want everybody to try this question, guys. Find the remainder when this polynomial x square plus 2x minus 8 is divided by x minus 3, and you don't have to do the division because by remainder theorem you automatically get it. So the theorem is on the screen there for you. So go ahead and try this question. Come on guys. So I want all of you to try. Very good. I can already see some answers. Excellent guys. So I want everyone to participate, guys. Please focus on the maths class here, right? Excellent guys. Superb. So how do we do this? You guys rock. That this is our polynomial fx, which is x square plus 2x minus 8, right? And we are dividing this guy by, what is our divisor? We are dividing it by x minus 3, right? So this guy is divided by x minus 3. Now I told you what is the trick. You just set the divisor equal to 0, right? So we set the divisor equal to 0. So or we can say or x equal to 3, right? So to get the remainder, we basically need to find f of 3. Excellent guys, very good. So to find the remainder is going to turn out to be f of a, right? Because here x minus a, so it's going to be f of a, which is basically f of 3. So the easiest way is, guys, you just set the divisor equal to 0, x minus 3 is 0. So you found the value of x, what you need to set. So remainder is going to be f of 3. Superb. So let's go ahead and substitute that. So if we put 3 in the polynomial, we're going to get 3 square plus 2 times 3 minus 8. So that's going to be 9 plus 6 minus 8. So that's 15 minus 8. Excellent. A lot of you have the right answer. The remainder is 7. So did you see the beauty of the remainder theorem? We found this without doing any division, right? So we've directly found the remainder. By the name you understand, it's remainder theorem. So the goal is to find the remainder without doing division. And what's the nice thing? When you're dividing a polynomial by x minus a, the remainder is going to be f of a. And the easy way to do it is substitute so make the divisor as 0 and substitute that value of x. Okay, excellent guys, excellent. Very good. Okay guys, now let's go ahead to the next point. So when x cube, so look at this next question here. When x cube plus 3x square minus kx plus 1 is divided by x minus 2, the remainder is k. Now you need to find the value of k. And whenever you get this remainder, you get the clue that you need to apply remainder theorem, right? So let's apply remainder theorem here. First, let's write the polynomial. Fx is basically x cube plus 3x square minus kx plus 1. So this is our polynomial, right guys? Okay. Now, long division, guys, that's the point. You can practice long division, but that's not the goal here. The goal is to find the remainder directly using applying remainder theorem, right? And it's very easy. When fx is divided by x minus a, the remainder is f of a. So you need to use that concept here. So by remainder theorem, what we can say? So by remainder theorem, right? Since we are dividing by x minus 2, right? So what is the remainder going to be, right? It's going to be, our remainder is going to be f of 2, right? How do we know that? Because x minus 2 is the divisor. So x minus 2, you set it to be 0. So or x is equal to 2. So we basically need to substitute 2, right? So very good. I can see some of you are trying. So go ahead. So remainder is going to be f of 2. And here the question says the remainder is k. So f of 2 is going to be equal to k, right? So guys, go ahead and substitute f of 2 over here. So we are basically going to get 2 cube plus 3 times 2 square minus 2k, right? Plus 1 equals k. So come on guys, pretty simple. Go ahead and solve the value of k here. So what do we get here? So this is going to be 8 plus 3 times 4. So that's 12 minus 2k plus 1 equals k. So I think we are getting 21 minus 2k equals k. So if we take this on that side, we get 21 equals 3k, right? So please check if I'm making any mistake or something, right? So just check it here. And look here, the remainder is k on this side, right? So what are we getting? So k should turn out to be, guys, 21 by 3 here, right? Simple. Because 21 equals 3k. So very good. I see a lot of you have the right answer. So k is actually 7. No, some of you are saying 21 by 2. No, guys, it's 21 by 3. It's minus 2k goes on that side. So you're going to get 3k equals 21. Very good. Excellent. I see a lot of you have the right answer. K turns out to be 7. Okay. So look at the question. Simple. We just applied remainders theorem. And what is our remainder? Look here. The magic is here. The trick is in this line, right? The remainder is going to be, when you divide by x minus 2, the remainder is going to be f of 2. Why? Because we just set the divisor so that you don't have any confusion of the sign. So it's a bit tricky because when you're dividing by x minus 2, the remainder is not f of minus 2, it's f of 2. And how you can follow that? X minus 2 is equal to 0. So set the divisor equal to 0. So look here, guys. Divisor, you set it as 0. Therefore, x equals 2 and you just substitute that. And after that, it's simply solving. Okay. So is that clear? So k is 21 by 3, right? Okay. So if you look at the solution, so we have 21 equals 3k. So k is 7. Excellent, guys. Excellent. Some of you made maybe a calculation mistake. Please check it. Right? Or you can check if there's any calculation mistake on my side. I think it's working out correct that k should be 7 here. Okay, good. So let's go to the next question. What should be added to this polynomial 2x cubed minus 3x squared minus 8x so that the resulting polynomial leaves the remainder 7 when it is divided by 2x plus 1? So this is a slightly more complicated question, but don't worry, we can just break down the question. So what is here? We are saying that what should be added to the resulting polynomial. So let's say k is added. Let's say a constant k is added, right? So what does our polynomial become, right? So our polynomial fx is going to become 2x cubed minus 3x squared minus 8x plus k. Okay, so simple. So let's say we are adding k to the polynomial. So this is going to be our polynomial, so that when the resulting polynomial, it leaves a remainder of 7 when divided by 2x plus 1. Okay. So if we apply remainder theorem, so by remainder theorem, so this is the important step, guys. By remainder theorem, can you tell me what should I say? The remainder should be f of what? So what should I substitute here, guys? Come on, try. Okay, so all of you please try here. Come on, guys. So I want everybody to try. Come on. So come on, everyone, try this question. What should it be? F of this thing, right? Some of you have already got the right answer. Great. But I'm asking, the remainder should be, when we are dividing by 2x plus 1, what should it be? Very good. I see some correct answers. Excellent. What should I put? So Shashank has the right answer. Nani TV has the right answer. Deathly Hallows, right? So very good. What do we need to do here, guys? Basically, our divisor is 2x plus 1 equal to 0, right? So x is going to be equal to minus half. Please note this trick. We are setting our divisor equal to 0, right? So that you don't make any careless mistake. So it's going to be f of minus half. Okay, so that's a little tricky one. Very good, guys, minus half. And so this remainder needs to work out to be equal to 7. Okay, so let's go ahead and substitute. Simple. So in our polynomial, we are going to substitute minus half. So we are going to get 2 times minus half whole cube, right? Plus 3 times minus half whole square, minus 8 into minus half, plus k equal to 7, right? So go ahead and solve this equation because the remainder is going to be 7, right? Simple. So you just need to go ahead and solve this. And on solving, what do we get here? So this is 2, I think we are going to get 2 times, this is going to be minus 1 by 8 here, minus 3 times, and this is going to be 1/4, right? And this is going to become plus, what do we have here? 4 plus k equal to 7, right, guys? Please check here. Pretty simple, right? Okay, so and what do we get? So if you simplify, this is going to be minus 1/4 here. So minus 1 by 4 minus 3 by 4 plus 4 plus k equal to 7. And if you solve that, you're going to get, so this is going to be minus, so 3 plus k. So from here we are going to get, so let's continue it here. We're going to get 3 plus k equal to 7. So excellent, guys. I saw a lot of you writing the right answer. K is going to be equal to 4. Superb. Yes, 4 should be added. Very good, because this value of k is going to turn out to be 4. So that's all. When you see, whenever you see this sentence, what leaves a remainder, what should be the remainder? You need to apply remainder theorem. Simple. And I showed you the trick how to apply remainder theorem so that you don't make any mistake. Set the divisor equal to 0, find the value of x and substitute it. Please see the trick here, right? This is where we've discussed it. Set the divisor equal to 0 here and find the value of x, and then you substitute it in your polynomial, and that value of x will give you the remainder. This is our line, right? The magic line remainder is going to be f of minus half, and that's equal to 7. And after that, you just need to solve. Very simple. Very good, guys. Superb. Many of you got it, and I hope you're getting the concept. Now let's slowly move on to the factor theorem. So before we go to factor theorem, can you tell me, is 5 a factor of 15? What do you guys think? Right? Can I say, is 5 a factor of 15? Right? Yes, because pretty simple. We know that 15 by 5 is equal to 3. So that's our quotient. And you know remainder is 0. Right? So 5 is definitely a factor of 15. Yes. Because the remainder is 0. It can divide 15. Now what about the second question? Is x minus 2 a factor of x squared minus 5x plus 6, guys? So please try this next question, the second question here. This was our first question, right? So first one is pretty simple. Can you tell me, is x minus 2 a factor of x squared minus 5x plus 6? I want all of you to try on the chat. Come on, guys. You guys are doing really well. I'm great to see all the excitement and all in the chat where people are answering. And guys, if you haven't hit the like button, please hit it right now and do share it with your friends so that we can have more people on these classes. And please subscribe to our channel, Manocha Academy. So come on, guys, go ahead and try this. So, right? So one way, how do you decide? You can do division, right? So you can check by doing division, or some of you are saying, very good, some of you are saying we can factorize this and check. Or what's another simple method? We can check whether by remainder theorem, right? So we can check whether it's going to give a, so what will be the remainder? So the remainder is going to be, when we divide this by x minus 2, the remainder is going to be f of 2, right? We set the divisor to be 0, so x is going to be equal to 2. So we just need to substitute 2 in our polynomial. So 2 squared minus 5 times 2 plus 6. So that's basically 4 minus 10 plus 6. And you can see the remainder is turning out to be 0, right? Okay, so we have used remainder theorem here. So look here, we used remainder theorem, and one you can do by factorization or by long division, and you can check that the remainder turns out to be 0. So yes, it is a factor because it's giving us a remainder of 0. Okay, so with that concept, let's move on to the factor theorem. So what does it say? That if fx is a polynomial, right? So any polynomial that you take, x square plus 2x plus 3, whatever, if you take a polynomial of degree greater than 1 and you take a, which is a real number, such that f of a is equal to 0, then we can say that x minus a is a factor of fx. Okay, so guys, clearly follow that statement. Let's understand it so that you guys are crystal clear. So what is it saying? That if you take any polynomial and if you take a number a, such that f of a means you substitute x equal to a in the polynomial and you get 0, then x minus a is a factor of fx. Okay, and is this easy to see? Absolutely, guys. Take a look here. We know that when you're taking a polynomial fx and you're dividing it by x minus a, right? So if you take a polynomial fx and you divide it by x minus a, by remainder theorem we've learned that what is the, so by remainder theorem we know that the remainder is going to be f of a, right? We need to substitute a in the polynomial. That's what remainder theorem taught us. And this statement is saying that f of a is 0. So when you know that when the remainder is 0, as we saw in the previous discussion, when remainder is 0, this means it's divisible. It's a factor, right? Therefore, we can clearly say that x minus a is a factor of fx. Simple, guys. So you can see that there's a connection between the remainder and the factor theorem. In fact, the factor theorem is using the remainder theorem. Okay, I'll repeat it again. I think some of you didn't catch that. No worries. Take a look carefully. So if you look at this example again, when do we say something is a factor? When it divides it, which basically when it's divisible, right? When that number is divisible or the polynomial is divisible, that means the remainder, as you can see, should be 0. Okay, so guys, now just carefully follow me. So this factor theorem is saying that if you take a polynomial fx, let's say any polynomial, and you divide it by x minus a, right? Then the remainder by remainder theorem is going to be f of a, because we need to substitute x minus a equal to 0. So basically f of a is going to be a remainder. And this factor theorem is saying if the remainder or f of a is equal to 0, therefore x minus a is a factor of fx, right? So very simple, that because the remainder is 0, obviously x minus a has to be a factor. Excellent, clear? And now if you look at the converse, that's also very simple. If x minus a is a factor of fx, which basically means when you're doing this division, so when the polynomial fx is divided by x minus a, right? And we know that x minus a is a factor. So when you do this division, the remainder has to be 0 because it's a factor. And what is the remainder by remainder theorem? F of a. So f of a is going to be 0, right? And don't worry if you didn't get it. We'll do some examples on it to make it crystal clear for you, right? So basically, if x minus a is a factor of fx, right, then f of a is going to be 0. So look at that connection. X minus a, then you need to substitute f of a as 0. So let's take a look at an example and really understand this. So this example says that show that x plus 5 is a factor of the polynomial x squared plus 3x minus 10. Okay, so guys, here's our polynomial x squared plus 3x minus 10, right? And we need to show that x plus 5, right? So we need to show that x plus 5 is a factor, right? And when you read this word factor means you need to apply factor theorem. So what factor theorem we need to apply? If it is a factor, can you see? We are going to use the converse here. So if x minus a is a factor, then f of a should equal to 0. So let's apply that here, right? So we are going to find, so what do we need to find here, guys? F of 5 or f of minus 5? Can you tell me? So do I need to find f of 5 or f of minus 5 here to prove the point? So guys, Please take a look and tell me, what do we need to find here? To show that x plus 5 is a factor, do we need to find f of 5 or f minus 5? Very good. Excellent, guys. Excellent. We need to find f of minus 5, right? We need to substitute minus 5 in the polynomial, because see the factor theorem carefully. If x minus a is a factor of fx, then f of a is equal to 0, right? So x minus a means that minus sign is going away, right? So which you can, right? So, or basically you can take x plus 5, so you can use our trick that x plus 5 equal to 0. So therefore, or we can say x equal to minus 5, right? We are setting the divisor always equal to 0. So, right? So we need to find f of minus 5 here. And let's see what's that going to be. So we'll substitute minus 5 into our polynomial. So let me write that clearly. So minus 5 whole square, right? We're substituting it in the polynomial, plus 3 times minus 5 minus 10. So what is this going to be? So this is 25, right? Minus 15 minus 10. And there you can see it's 25 minus 25. So f of minus 5 is 0. Therefore, since this is 0, therefore x plus 5, right? Or we can say x of minus 5, right? Because x minus a is a factor, or basically x plus 5 is a factor. Clear? So very simple, guys. Very good, you guys got it. So that's how you do it. So we need to carefully substitute the right value, which was minus 5 here. And since the remainder has come out to be 0, we have proved that it is a factor. So best part, you don't have to do any factorization. You don't have to do any division. These are all shortcut tricks with the remainder and factor theorem, just by simple substitution. We are just substituting the value of x in the polynomial. That's the whole beauty of remainder and factor theorem. There's no long division done. There's no factorization done here. Just substituting the correct value gives you the answer really fast. Okay, guys, ready for this next question? What are the factors of 2x squared minus 11x plus 5? Okay, so as we are using remainder and factor theorems, guys, use the right theorem in this class rather than doing with factorization or long division. I think you know that already, but we are trying to practice the factor theorem or the remainder theorem here. So come on, guys, try. So what are the factors of 2x squared minus 11x plus 5? So from this list, I've got x plus 5, x minus 5, 2x plus 1 and 2x minus 1. Which one do you guys think? Okay. Alright, great to see all of you interacting and giving the answers here. And guys, please hit the like button and hit the subscribe button and for our channel and the notification bell so that you don't miss out on any live classes. And please share it out with your friends. Come on, guys, try this. So how do we do this? Again, can you see the clue in the question? What are the factors of? So I think we need to apply factor theorem here, right? Right? We need to apply factor theorem. So since it's a multiple choice question, we need to select from these options. We've been given x plus 5, x minus 5 and so on. So to check it's a factor, what do we need to do? We basically need to substitute this value, right? So for x plus 5, we are going to substitute, since x plus 5 equals 0, so we are going to substitute f of minus 5. So for this option, you should do this. For this option, you just find this, right? For this option, what do we need to do? Minus half, right? Can you see 2x plus 1 equals 0? So it's going to be minus half. And for the last option, we need to substitute x as half. So that's the trick, right? By using factor theorem, guys, just substitute these values in the polynomial, where our polynomial here, fx is this, right? So our polynomial, basically, let me write it down here again. So this is our polynomial, fx equals 2x squared minus 11x plus 5, right, guys? And you just need to substitute the values. So go ahead and make the substitution and tell me which ones are factors of this polynomial. Come on. Okay. So it should be pretty simple. Let's quickly go ahead and try it out. So the first one, let's see, it's going to be 2 times minus 5 square minus 11 times minus 5, right, plus 5. Come on guys, help me out here, find this out. So what is this going to be? So this is going to basically work out to be this is 2 times what do we have here, right? So 25, so 50 plus we have here 55, right? So this is, and plus another 5. So this is definitely not working out to be 0, because I think we're getting 60 plus 50, 110. Please check my calculations if I made a mistake. So the first option, x plus 5, we need to substitute f of minus 5, right? Oops, I think I erased something here accidentally. Right? So if we substitute that, we are getting 110. So this is not a factor because the value should turn out to be 0. Now let's try f of 5, guys. Come on. So pretty simple. So 2 times 5 square minus 11 into 5 plus 5. And what are we getting here? 50 minus 55 plus 5. Great. Oh, we got 0 here, right? So if you substitute 5 into the polynomial, you can do the working and find we are getting 0. So x minus 5 is a polynomial. And similarly, guys, you just need to substitute these into the minus half and half into the polynomial. So see, simple trick, without doing division or without doing factorization, we are finding the answers. Come on, guys. So try it. So what is the next one going to be? Okay, so let's try this one. So this is going to be 2 into minus half whole square minus 11 times minus half plus 5. So all of you go ahead and solve this. And similarly, this one is going to be, so what do we get here? 2 times, so this is going to be 1/4 minus plus 11 by 2 plus 5. Oh, okay, no, that's certainly not 0. So I won't even bother to calculate it. It's basically not equal to 0, right? So I checked that. It's turning out not equal to 0. So therefore, this is not a factor. And let's go for the last one, right? 2 times half square, because we don't care about the value. It's whether it's not a 0 or not, that's what we need to check. So 2 times half square minus 11 times half, right? Plus 5. And what do we get here? Guys, come on, let's do this. So we are getting half minus 11 by 2 plus 5, right? And yeah, that's going to turn out to be 0. Okay, so check my calculations. I think I did the right values there, guys. So please check. So this is going to be turning out to be B and D. Okay, so this is the this is the quick way to find without doing any divisions or factorizations. Just we are using the factor theorem, and be careful while substituting, because the main thing is for x plus 5, we are substituting minus 5. For x minus 5, it's f of 5, and so on. Okay, so guys, please take care of that. And whatever you get when you get 0, that means this thing, x minus 5 or 2x minus 1 is it's a factor, because it's dividing and giving you a remainder of 0. All right, simple. Okay, let's take a look at another question then. Great, guys. So without division, show that x cubed minus 3x squared minus 13x plus 15 is exactly divisible by this. So this is another interesting question, guys. So how will you do this without doing long division? Somebody's asking, I think Rekha Bansal is asking, can we do long division? If the question, like this question says without doing division, so here you're not allowed. In some questions you can do, but you know, the factor and remainder theorem, that's the goal. It's much faster if you substitute values, right? Because while doing long division, you may make mistakes, right? Because you have to change the sign and do it carefully. Here, it's much easier and faster. Okay, so very good. Some of you are saying factorization. So how do you guys do this? So without doing the real division. So one thing is, if I say, let's take an example. If we take a number such as 18, right? We know it's divisible. So if any number, like let's say a number 18 is divisible by 6, we can say that it's also divisible by, so the number is also divisible by 2 and 3, right? Why? Because we know that the factors of 6 are 6 is 2 times 3, right? So if any number like 18 or any number, let's say it's divisible by 6, we can also confidently say it's divisible by 2 and 3, right? Do you guys agree with me, right? Because it can be divisible. So if a number is divisible by a certain number, it's also divisible by its factors. So we're going to apply this technique here, and let's see. So since we are dividing by this guy, right? We are dividing by x square plus 2x minus 3. So we want it exactly divisible by that. So let's go ahead and find the factors of this guy. So what is the factors going to be, guys? So you know it's going to be x plus 3 times x minus 1. So that means our polynomial fx, right, if it needs to be exactly divisible by this, it also needs to be divisible by each of the factors. Makes sense, right? Because if any number is divisible by 6, means it's also divisible by 2 and 3, the factors of 6. So similarly, if it needs to be divisible by this x square plus 2x minus 3, it needs to be divisible by. And why are we doing it? Because our this time our divisor is not a simple, it's a polynomial in degree 2. It's a quadratic polynomial, right? So we are breaking it down into its factors, right? So now basically we need to prove, so we are required to show that our polynomial fx, which is x cubed minus 3x square minus 13x plus 15, we need to show that it's divisible by, so we need to show it's divisible by x plus 3 and also divisible by x minus 1. So guys, how will you show that? So see, we've broken down the question. Now it should be pretty simple for you guys. Come on, please try this. And great to see all of you participating in the chat and thinking of the questions here. So guys, please try this thing. What will it be? Okay. So to show that it's exactly divisible means it's a factor, right? So since it's a exactly divisible means, this word means that the thing is it's a factor, right? So again, we can apply factor theorem. So we are going to apply factor theorem to this question. So to show that x plus 3 is a factor of fx, how do we do that, guys? Pretty simple. We need to, so by factor theorem, we need to show that f of minus 3, we need to check, is it equal to 0 or not? Okay. So similarly here, guys, we need to check that f of 1 is 0 or not. So basically you just need to substitute minus 3 in the polynomial. So minus 3 whole cube minus 3 times minus 3 square minus 13 times minus 3 plus 15 and so on. And same way here for 1. So 1 cube minus 3 times 1 square minus 13 plus 15. Okay, guys. So that's what you need to check here. Okay. In both these cases, and you can go ahead and do the calculation. You will get f of minus 3 as 0 and f of 1 as 0. Go ahead and check that, right? So, and you'll get f of 1 as 0. Clear? So what is the trick we did here? Since our divisor was more complicated here, we had x square plus 2x minus 3. We broke it down into its factors, right? And we applied the logic that since we want the polynomial to be divisible by x square plus 2x minus 3 means it should also be divisible by its factors. Okay. And how did we show that? Using the factor theorem, we found the remainder, and that's turning out to be 0 in both cases. So therefore we can say these two guys divide the polynomial, hence x square plus 2x minus 3 is also dividing our polynomial, or our polynomial is exactly divisible by x squared plus 2x minus 3. Clear? Okay, guys. So I hope you got that, and so I hope the remainder and factor theorem is crystal clear to you now. So guys, I have a homework question for you. Is x cubed plus x squared plus 3x plus 115 a multiple of x plus 5? Okay. So is it a multiple of this guy? Let me put the brackets also there. Okay. So is it a multiple of x plus 5? And you need to give me the reason why. So hint is you need to apply either remainder theorem or factor theorem, and you need to tell me, is x cubed plus x squared plus 3x plus 115 a multiple of x plus 5 and give reason. Okay guys, and do write your answer in the comments below. I look forward to reading all of your comments and I promise to reply to them as soon as possible. I make it a point to read everybody's comments and reply to them as soon as I can. And guys, it's really great to see some of you writing it immediately after the live class. So please give this homework question a try and go ahead and re-watch this video to really absorb the remainder and factor theorem, because sometimes the wording gets complicated, but once you catch the trick, which I've explained to you in a very simple way, I'm sure you'll find it easy. And guys, do check out our website manochaacademy.com. We have these awesome courses for you available at a big discounts, and we also have special live classes going on in these courses on our website where I'm taking special live classes. We have interactive videos, quizzes and questions, and you get direct replies from me. So do check out the links below, the links which are given below. And guys, thanks a lot for your love and support. It's great to read your comments. So if you haven't subscribed to our YouTube channel already, what are you waiting for? Hit the subscribe button right now. Click on the notification bell so that you don't miss a single live class or any of the videos we upload. So guys, thanks for being here on this chat and attending the live class. Thank you guys. I hope you found it much easier now, because remainder and factor theorem sometimes confuses folks, right? But I hope I made it simple for you. So do give us the feedback and let me know what other topics you'd like in physics, maths and chemistry. We're having live classes these days daily at 8 p.m. So guys, I'd love to hear your feedback, and thanks a lot for your support and being there in these live classes, and I hope to see you in the next one too. And don't forget to check our courses on our website manochaacademy.com. We've also recently launched the chemistry CBSE class 9 course, which is right here for you. Okay, all right guys, take care, please stay safe and utilize this time to do well in your studies, do your revision, also take breaks, relax, take care of your health, and keep studying guys, keep learning, and see you in the next live class. Thanks for attending. Bye.